Hey, this is Mr. Aiden. This is the AP Calculus AB exam. This is the 2019 exam. We're going to finish this off with number 6. So let's take a look at number 6. Number 6, we have functions f, we have g, we have h. They're twice differentiable. Twice differentiable, which means we know that g of 2 is equal to 4. We know h of 2 is equal to 4. That is two things we know. And we know that the line y is equal to 4 plus 2/3 x minus 2 is tangent to both g and to both h at the exact same point. And we want to first know h prime of 2. So we want to know the slope of the tangent line of h. The slope of the tangent line of h. Well, if y equals 4 plus 2/3 x minus 2 is the slope of that, then think of that in y equals mx plus b format. What is the slope of the line? The slope is equal to 2/3, and that a was worth 1 point. Nothing harder than that, just finding the slope of the tangent line, which is the definition of a derivative. Let's take a look at b. b gives us a new function. We know a of x is equal to 3 times x cubed h of x, and we want to know what a prime of x is, the derivative. So let's take the derivative, a prime of x. We got to use the product rule here, so we're going to multiply by 3. We have 9x squared h of x plus 3x cubed h prime of x. And so that is the expression for a prime of x, and that was worth 1 point. Okay, that was worth 1 point, finding that a prime of x. Now we're going to find what a prime of 2 is. What a prime of 2 is. So we have a prime of 2, and we're going to plug 2 in there. We have 9 times 2 squared times h of 2 plus 3 times 2 cubed h prime of 2. And so that a prime of x, they not only give you a point for the product rule, but they give you 1 point for kind of that substitution of a prime of 2. Now we're going to find out what this ultimately equals. We have 9 times 4, and we have h of 2. Remember, what did they say h of 2 is equal to? Is equal to 4. Plus 3 times 2 cubed, which is 8, times h prime of 2. We come back to a. What did h prime of 2 tell us? We had 2/3. And so when I add all of that up, I get 144 plus 16, which gives me 160, which gives me my third point on problem B. So that was A and B for number 6. Let's jump to letter C. Now, letter C is probably the most complicated out of this problem, but if we take it step by step and point by point, we're going to take a look at each one of these little details. And it says the function h of x equals x squared minus 4 over 1 minus f of x cubed. And we want to know, it is known that the limit x, as x approaches 2 of this function h of x can be evaluated using L'Hopital's rule. Okay, so we want to use this limit of x approaches 2 of h of x to find f of 2 and f prime of 2. Now again, this looks like it's really, really difficult, but it's not too bad. So what do I know? I know that the function is continuous and differentiable. And so I know the limit as x approaches 2 of h of 2 is equal to 4, right? Because I know h of 2 is equal to 4 at this point, which means the limit as x approaches 2 of h of 2 is equal to 4. Because that point is defined, it is continuous, it is differentiable. So what does that mean? What does that mean? That means if I take this limit as x approaches 2 of h of x, I know this is equal to 4. This is equal to 4. And I know this is going to be equal to x squared minus 4 over 1 minus f of x cubed. Now what did they tell me? I could use L'Hopital's rule. So this must mean that it's going to become 0 over 0. So remember, this is as x approaches 2. Now you can see we have 2 squared minus 4. That equals 0, doesn't it? Which is really nice on the numerator. Which means on the denominator, what does that mean? that means 1 minus f of 2 cubed has to equal 0 as well. Which means 1 minus what cubed equals 0? That has to equal 1. So I know f of 2 is equal to 1. That is incredible. I was able to find out what f of 2 equaled using this value here. And so f of 2 equals 1. And that was my amazing way to do this. Yeah, I'll say it's pretty amazing. Okay. Now we go on to the second part of the problem because I want to find out what f prime of 2 equals. Well, remember, I can use L'Hopital's rule, and I know the limit as x approaches 2 of h of x is equal to L'Hopital's rule. So I can take the derivative of the numerator. What's the derivative of x squared minus 4? It's 2x. What's the derivative of the denominator? Is 1 minus 3 f of x squared times f prime of x. And so now I can plug in some numbers because I know it's differentiable. I know this is able to figure out this is not going to equal an indeterminate form anymore. So I can plug 2 in for things, can't I? Now I know all of this limit equals 4, don't I? So we have 2 times 2 on my numerator. I have 1 minus 3 times, do I know what f of 2 is equal to? I sure do. Remember back here, it was equal to 1. So we have 1 squared times f prime of 2, and all of that nasty guy equals 4. And I can do a little bit of algebra here. I can multiply this guy out here. Oh, sorry. This guy is 0, isn't it? Okay, on that derivative. I am so sorry. That derivative of 1 minus f of x cubed is going to be negative 3 f of x squared times f prime of x. So no 1 on the top of that. Sorry. So I divide by 4. That 4 and 4 cancel out. This f prime of 2 is over here. So f prime of 2 is equal to, if you do all your algebra here, negative 1/3 on that guy. So that was kind of complicated, but we were able to do it using what we know. So this is worth 4 points, believe it or not. Kind of a 2-point problem for this one. We get 1 point for here. You can see what are we going to be able to do here is this 1 point for getting this kind of concept in here. And then over here, using L'Hopital's rule, using that derivative correctly, not like Mr. Aiden. And this 1 point right here is going to be 4 points on this problem. 2 points for the first part to find f of 2, 2 points for the second part to find f prime of 2. Let's finish out this problem right here. And so we are right here. It says it's known that g of x is less than h of x from 1 to 3. Let k be a function satisfying g of x is less than or equal to k of x, which is less than or equal to h of x for 1 to 3. And we want to know, is k continuous? Is k continuous? And we have to kind of explain our answer for, is k continuous? Well, what do we know? What do we know? G and h, these functions are differentiable. Okay? And they're twice differential, which means they must be continuous as well. Okay, and which means that the limit as x approaches 2 of g of x is equal to g of 2. We already know this. It's equal to 4. Okay, we've already said this, haven't we? Because that g and h, we know they're differentiable. They must be continuous because their points are defined on these values. Okay, and I know the limit as x approaches 2 of h of x is equal to the same value as h of 2, which is equal to 4. Okay, that value is defined. And what do I know? I know g of x is less than or equal to k of x, which is less than or equal to h of x, which means I can use what's called the squeeze theorem. The squeeze theorem. Squeeze theorem is exactly what it sounds like. If I know that g of x is equal to 4, and I know h of x is equal to 4, and I know it's less than or equal to or less than or equal to, then what does this k have to be? It has to be 4, which means the limit as x approaches 2 of k of x has to equal 4. And k of 2 has to equal 4, which means this is not only differentiable, but it is continuous value of the squeeze theorem. Believe it or not, all of that justification was worth 1 point. So we have problem number 6, 1 point for A, 2, 3, 4 points total for B, 5, 6, 7, 8 points, and then the 9th point for D. This was the 2019 AP Calculus AB exam number 6. See you guys. Talk to you later.